Hello friends, in this video we start a new topic of the 12th class physics, that is electrostatic. It's very interesting and it's very useful also. So first we will discuss what is electrostatic. When a charge particle is in stationary, means the charge particle in a state of rest, and because of that what is happening means there may be the force, there may be the electric field, there may be the electric potential, there may be the electrical energy. Okay, so we study all these electric force, electric field, electric potential, electric energy, and taking the charge particle in a state of rest. So this is the branch of physics in which we study all these things, taking the charge particle in a state of rest. This is called electrostatic. So electrostatic is very useful. So here in this we have to study something about the charge, then we have a interaction of two charges, then electric field, and after that very important term electric flux, and then Gauss theorem. This is comprises the first part of the you can say electrostatic and electric field. Then second we have to study electric potential and capacitance. Okay, so this will come in the unit 1. This two will be come in the unit 1. So first we start with the electric charge. Electric charge. Okay, first term we have to study charge. Generally we use this word in our social language also. Okay, and I am giving some example. In a literature also we use this word. So as the final date of the examination is announced, the students is charged to study. Is it? One more example. As the Mahendra Singh Dhoni heard only 2 overs left for the winning, he is charged and starts hitting sixes. Clear? Charge is a word. So generally what do you think? Just see, suppose we have a charge particle. Okay, the charge particle will experience some force. So some force is exerted on the charge particle because of some electric field, that we will study some other topic. But if there is a charge only, then it can exert a force on it. If there is a no charge, there will be no force. हम लोग ऐसे बोलते भी हैं, अरे उसमें तो कोई बात ही नहीं है, वो क्या करेगा? यदि आप में कोई बात हो तभी आप कुछ कर पाओगे. Means if you have a potential, then only you can do some work. Similarly, if there is a charge particle, so if a charge particle, then only it experience a force. Okay, so this is one of the definition. The charge particle is an intrinsic property, because of that it experience force in a presence of electric field. Clear? One more theory is given, that is called the atomic theory of charge. So you know all the substances, whether it is a solid, liquid, gas, ये पेन है मेरे हाथ में, ठीक है, ये दूसरी पेन है, ये बोर्ड है, मेरी शर्ट है, whatever, okay, ये पानी का गिलास है, whatever, everything is made by molecules, that you know, है ना, हर चीज molecules से बना है. So molecule is also made by atoms. Okay, you know, so just take one example. Suppose we have one piece of copper. Okay, one piece of copper. So it is made by atoms. It is made by atoms, and you know atoms containing neutron and proton within its nucleus, and electrons are revolving in a suitable orbit that you studied. Okay, so atom is having some neutrons, some protons. These are within the orbit, these are within the nucleus, and electrons are circulating in a particular orbits. So in each and every atom, the number of proton and number of electron always be equal. That's why it is in neutral. But by any XYZ reason, suppose you take out some of the electrons. Suppose you take out the electron, so you can say it becomes charge. So by removing or adding electron, we can charge the substance. Clear? So in simple language we can say the charge is what? The charge is, we can say, excess or lack of electron as compared to proton. In an object that will causing a charge. Is it clear? Now just we understood what is charge. Okay. Now whether the charge is a scalar quantity or vector quantity. So you know the electrical charge is a physical quantity, and all the physical quantity will under two categories, either it will be a vector quantity or it will be a scalar quantity. So it is a scalar quantity. So charge is a scalar quantity. Clear? Scalar quantity. What is its SI unit? SI unit of the charge. SI unit of the charge is Coulomb. Okay. Its SI unit is under the name of scientist Coulomb. Okay. So Coulomb is a very big unit. So we say 1 coulomb, if the charge is 1 coulomb, so it is a very big charge. Okay, you should know one thing, when we are charging a substance by 1 coulomb charge, so it's very big charge. Okay, remember it requires about a 9 meter radius of sphere to make this amount of charge. Okay, so huge 9 meter radius that we cannot take in our physics lab. Okay, 9 meter radius sphere we required to make a 1 coulomb charge. That we will discuss in some other topic. So here its SI unit is coulomb. Okay, remember when you are writing coulomb, the C should be small, it should not be capital. Okay, when you write in a short notation means 1 coulomb, then the C should be capital. When you write a full name, so C should be small. Clear? That is the procedure of writing the units. Now the units, SI unit of the charge is coulomb. So how the 1 coulomb is defined? So 1 coulomb, it defined, you know, the fundamental physical quantity that you studied in the last year. Fundamental physical quantities, okay, that means the length, mass, time, then electric current, luminous intensity, temperature, okay, amount of substance, angle and solid angle. These are the fundamental quantities. So how the coulomb is derived? It is a derived quantity. So coulomb is derived from the current into time. Okay, we say ampere into time, second, ampere into second. Okay, so 1 coulomb can be defined as a 1 ampere second, 1 ampere second. Clear? So you can take some other units also. You have seen particularly in our nowadays we are using a mobile phone very frequently. So you have seen the charger of the mobile, or the power bank, or your battery of the mobile. There is written milliampere second, milliampere hour, like that. Okay, so what is that? Ampere means it is a unit of electric current, and second it is a unit of time. Okay, so ampere into time, that will be charge. So milliampere second, milliampere hour, whatever it is, all these the unit of charge. Okay, but SI unit is coulomb. So we can say 1 coulomb is equal to 1 ampere second. So if you have a milliampere second, so it will be converted. Clear? You know 1 ampere is equal to 1000 milliampere. Clear? So we can say 1 coulomb is equal to 1000 milliampere second. We will see the properties of charge. First property, the charges are additive in nature. Additive. Okay, what does it mean? Just like a charge is a additive. Just like the numbers we are adding, negative, positive, similar to that, charge are additive. Okay, means suppose we have a substance and some part of charge is, suppose here Q1, here the charge is Q2, here the charge is Q3, maybe negative, positive. Okay, so when we take a total charge on the substance, simply you have to add. So which type of addition? It's the algebraic sum of the particular total charge will be algebraic sum of the charges. Okay, this is the additive in nature. Is it clear? Second property is the conservation. Conservation is a conservative. Charge is conservation of charge. Okay, means as you know, the law of conservation of energy, law of conservation of mass, law of conservation of momentum, similar to that, the law of conservation of charge is also there. Means the charge neither be created nor it be destroyed. The total charge of the system remains conserved. So how can we say one thing is charged, one thing is not charged? Say one example we will take. Suppose you rub some plastic comb with dry hair. So you know it has some charge capacity. It has a tendency to pick some small parts of the paper. It can attract the small pieces of the paper. Okay, that is because of charge. So what is happening there? It is charge. So the charge is created? No. There will be the transformation of electron from one part to another. So if one is positively charged, so other definitely must be negatively charged. So charge is always conserved. Now third property is that quantization of electric charge. Okay, the third property is that quantization of charge means the charges are quantized. Okay, so it is a integral multiple of some particular charge. So what is that? Charges are integral multiple of a particular charge. Quantization. So when we find a charge on any substance, it will be multiple integral of a particular charge. And what is that particular charge? That particular charge is the charge of one electron. Okay, so we can say this is the quantization. So plus, minus and E. So when we are adding the electron, suppose if we have a total number of electrons is such, okay, then we are adding some electron, so it will be negative charge. That is, excess of electron is called negative charge, and when you are removing electron from any substance, it becomes a positive charge. So excess, or like we know, that is so that comes from the electron only. So the number of electrons, how many number of electrons are added, how many number of electrons are taken out, that will cause the charge on a particular substance. So that depends upon the number of electron only. So you know the charge of one electron. Okay, the charge of one electron, say that is 1.6 into 10 raised to power minus 19 coulomb. So whatever the charge on any substance, that will be the multiple of this factor always. So we have to multiply n with this. If we are adding electron, so it will be negative. Okay, when we are removing electron, it will be positive. Clear? But it should be the multiple of E, and E is 1.6 into 10 raised to power minus 19 coulomb. Clear? See, sometime when we are considering the point charge, okay, then we very keenly take this phenomena is taken into account. Means when we are discussing microscopic point of view, then we are very determinate about the quantization principle. But when we take a macroscopic point of view, then we are not very keenly observe the quantization principle. Okay, just take one example. Suppose it is asked how many students are present today. Suppose the principal asks total number of students in your class. So you will be very much specific number in your class, means be 45, 46, whatever. Similarly, total number of students in a school, that also it will be very specific number. Okay. Similarly, if so many viewers are watching a cricket match in a stadium, okay, so that also be a specific value, means there will be a specific number because they have bought some ticket and the number of viewers can be calculated. Clear? But suppose one leader is delivering some lecture, okay, and so many spectators are watching their lecture. So if it is asked how many spectators are there, so it is not considered very keenly the particular number. It will be simply maybe 20,000, 24,000 like that. Means at that time we are not counting each and every person. So that you can say that will be a macroscopic point of view. So when we are taking the macroscopic point, so generally we not observe the exact number of electron. Okay, we will not consider the exact number of electron. Okay, and the last property is that, fourth and the last property is that invariation. Okay, means the particle is in motion, there will be no change in charge. Charge remains invaried. Okay, so it is not depending upon the velocity, it is not depending upon the any physical quantities. Okay, like a temperature, pressure, etc. So it is a invariant. Clear? So these are the properties of charge. Once again, the properties of charge we can write this in terms of laws also. Means the laws of invariation, laws of quantization, laws of conversion, laws of addition. Clear? Similarly, we can say the property, the charges are additive, charges are quantized, charges are conservative, charges are invariant. Clear? Now we will see how to charge. Okay, how to charge. There are 2-3 simple methods of charging the substance that we will see in one activity also. The first method we will see the charging by friction. It is called the frictional charge. So whether the material is conductor or insulator, when you rub two substances, okay, so they will be charged. Means the electron will transfer from one body to another body. As you took one example, when you rub the comb with the hair, so it has a tendency to adhere the very small paper pieces. Okay, that we will see in one activity. Then that is charging by friction. So when two bodies are rubbing, so the electrons are transferred. So it transferred from one body to another body. When you rub the glass with a fur, okay, when you rub the glass with a fur, then what will happen? When you glass rod with a fur, so what will happen? The electron is transferred. Means the electron is transferred from glass rod to fur. Means the glass will be glass become positively charged, and that fur piece become the negatively charged. So this is the charging by friction. When you are inside the blanket in a cold season, and when you just put your hand with the blanket, you will be charged. Next, charging by induction. By this process, by the induction process, we can charge only the conductors. Now take two conductors near to each other. Okay, one conductor and another. This is a charged conductor, say C charged conductor C1, and this is the uncharged conductor C2. This is also conductor, this is also conductor. When any conductor is brought near to another conductor, one of them is charged. So what is happening? So all the electrons in the conductor will move toward the positive side, this side. Okay, electron within this become this side, and this become positive. Okay, so when you brought a conductor C1 near to another conductor C2, this will happen. Now just take this connect with the earthing. This is called the circuit diagram of earthing. When you connect this part to the earthing and immediately you remove this, okay, so what will happen? This part move to the earth and this become negatively charged, and immediately just remove this one also. So what will happen? Means you are brought a conductor, you have connected the second conductor with earth, it becomes charged. Clear? So that is the method of induction. And third, charging by conduction. Suppose we have a charged particle A. It has a charge, it's a conductor, and we have another particle same type of nature, but it's uncharged. Charge is 0. It has some charge. So when you touch these two conductors, they will share their charge. Okay. So what will happen when you touch these two? So when you touch these two A and B, they will share the charge, and the charge will be distributed. If the shape and size are same, so both will take half charge. So now the A will have Q by 2 and B will also have Q q by 2. That depends upon their shape and size, that we will discuss in some other topic. Okay, so when you touch two conductor, one of them is charged, so they will share the charge, and by this we can charge the uncharged conductor. Remember, the total charge is constant. Remember, always charge remains conserved. Here also, in a friction also, charge is transferred from one body to another body. Total charge is conserved. Is it clear? So in this video up to here only. In the next video we will see the interaction of charges. Okay, so keep study. Thank you.